up, mathletes? Whoop, whoop. All right, let's do this. Okay, team test. Analytic or synthetic? Trick is, if it has a coordinate grid, it's analytic. If it doesn't, it's synthetic. So we got analytic here, synthetic here, analytic here. It's that easy. A lot of people got stuck on this a little bit, not because it was hard, but because of the, what is it? I think it's the feed. Well, let's just go down the plane. Plane B, yep, that works. That's the name for the plane. VWY, let's say VWY, that's the one. Those are collinear points. Remember, you have to have 3 non-collinear points. So you need at least 1 point off this line to make it a triangle. That's why we're not going to click that one. How about VWX? VWX, that's a point not on the line. Those are non-collinear. So that makes a triangle. How about plane M? No, that's a line, not a plane. Plane RV, RYV, let's see. RYV, those are non-collinear. So that's a plane. And VWZ, let's see. VW, Z's not even on the plane. It's underneath the plane, so that doesn't work as well. Okay, so it has to be non-collinear points. That's why the one line didn't work. So let's look at this one. It's kind of hard to see on the camera, but you can see where they intersect is this line created right here, right? And that line, now it has a point S. If we had another point like T, we could call it line ST, but since we don't, we're just going to call it line M. It has that M by it, so it is line M. All right, which 3 points are collinear? Well, let's see. GEC, GEC. Well, those are not collinear. They're not even on the same plane. How about AEC? AEC. Those are collinear. I'm going to cross the first one out. And since we found our answer, let's keep going, though. How about DFB? DFB. Oh, those form a triangle. They form a plane, but not a line. And HFD, HFD again. Those are not collinear. So our AEC is correct. That's page 1. This is going quick. Slows down a little bit in the back half, but front half's pretty quick. Okay, I kind of laughed at this one. So you may get more than one. We only have 3 things, but we need to match it to what makes sense. What's a tabletop? Well, tabletops looks like this, which that looks like a what? That looks like a real-world example of a plane. Railroad track, right? It's going across. That looks like a real-world example of a line. And the dot on the letter I, well, if we have the letter I, that dot, doesn't that look like a real-world example of a point? Okay, a real-world example is going on. Now, as we're going to get the math of it, so let's draw this one. What are the values of x and BC given the following information? B is between C and D. That means we have a line segment, and we know C and D are the endpoints because B is between them. CB is 2x, and BD is 4x, and CD is 12. Well, don't I know if I add 2x plus 4x, it should equal 12? Let's do that. Which that is 6x equals 12, or x equals 2. Boom. So we have the x part, but it also wants us to find BC. Well, we know that BC is 2x, so BC equals 2 times 2, which equals 4. And there we go. Boom. So this next one. Q is between P and R. We have that already. PQ is 5x minus 10. Perfect. QR is 3 times the quantity x plus 4. Great. And PQ is congruent to PR. That means they're the same line. If they're the same measure, they're equal to each other. So now the equation I can set up is 5x minus 10 equals 3 times x plus 4. Distribute. 5x minus 10 equals 3x plus 12. So I'll subtract the 3x over and add the 10. 2x equals 22, or x equals 11. And this one just said to find x, so this was actually an easier problem, right? Okay, let's move on up. Again, pause me if you need to at any point. I just kind of boot scoot boogie through these. On a straight highway, the distance from Loretta's house to a park is 43 miles. Her friend Larry lives along the same highway between Loretta's house and park. So we're going to do Loretta's home, or chimney smoke, right? This is Loretta. And she's going to the park. There's trees at the park. And Larry is somewhere in between here. He's got his home. That front door there. He's got a chimney too. This is, or is that Larry? Yeah, Larry. Okay, and we know the distance from her house to the park is what? 43 miles. And from Loretta's house to Larry's house is 31 miles. So how far is it from Larry's house to the park? Well, that's just 43 minus 31, which equals what, 12? So Larry and his 12 miles, don't forget, we need to put on our units when they give them to us. Larry lives 12 miles from the park. Boom. Okay. This last one, during the archaeological dig of a shipwreck near St. Augustine, a bronze bell and a pewter spoon were found. What is the distance between the artifacts if each grid represents 1 foot? Round your answer to the nearest tenth. Let's do that. So, first of all, right, we're going to find that distance from here to here. We don't really need this. I just want to show you what distance it's asking us, remind you. And we have the points 214 and 12.3. Okay? So remember I told you to draw the picture, right? So we know that the distance is equal to the square root, which is draw that squared plus squared, and then I'm going to put my x's in here. So I'm going to connect my x's. 2 minus 12. We don't care that it's going to be negative. The square will make it positive. And then 14 minus 3. All right, and what's that going to be? That's going to be 10 and 11 here. So this is going to equal, what's 10 squared? It's 100. And it's negative 10 squared. Yes, I'm sorry. Negative 10 squared. However, that becomes a positive 100. And 11 squared is 121. So this equals the square root of 221, which, if we do that, it says to round it to the nearest tenth, so 14.8, but that 6 makes the 8 round up to a 9. So it is 14.9, and each grid represents a foot, so that's 14.9 feet. So the artifacts are 14.9 feet apart. Oh, good stuff. This is formula, not so bad. Okay, this one's an interesting problem. Required you to use a little bit of remembering about slope triangles and all that. Find the coordinates of A if m is 6, negative 1. So we're going to go to 6 and down 1 right there. So we've got our M point. We know that AM is congruent to MB. That's awesome. And B has the coordinate of 8, negative 7. So 8 and then down, negative 7, right? And that's B. Now here's what I'm going to do to find the other point. To find the distance, I could go about this 2 routes, right? Okay? I could find the distance between these 2 points and then multiply them times 2 because it tells me, hey, they're the same distance. So let's try that. The distance between M and B. So I want my, oh, I gotta move the screen up though, don't I? Let's see. MB equals the square root, right? We're just gonna plus squared plus, and since that is 6, 1, is that a negative 1? Yeah, 6 negative 1 to 8, negative 7, 8, negative 7, right? I'm going to have 6 minus 8 and negative 1 minus negative 7. And so that's going to be what? Negative 2 squared, and that's going to turn into a plus, negative 1 plus 7 is 6 squared. So this is going to equal the square root of 4 plus 36, which equals the square root of 40. And don't forget, when I get that, I'm going to multiply the whole thing times 2, because there's two sides, right? There's this distance to here, and then there should be a second distance, which is equal. So, I don't know why I put the 2 there. I'm going to put the 2 right here. So let's try that. I'm just going to put in 2, second function, square root 40. That's approximately 12 point, does it say to round it? What is the measure of AB? Oh! I guess we could just leave it 2 square root 40. Which would also, just so you know, be the same as square root of 160. But that's a different story for a different day. Or you could estimate it to be about 12.6. Or we could try the other method, which is, hey, let's do, take this and go back. Since I go back 2 and up 6, then I'm going to go back 2 and up 1, 2, 3, 4, 5, 6, and find my other point A, which is the point, what? 4, 5. And that point 4, 5, so I'm going to have the point 4, 5 for A. And for B, I'll have 8, negative 7. So I'm going to have the square root of blah squared plus blah squared. Here I'm going to subtract my x's. 4 minus 8. Over here I'm going to have 5 minus negative 7. 4 minus 8 is negative 4. This turns into a plus, becomes 12. And I end up with equals the square root of negative 4 squared is 16 plus 144, which equals the square root of 160, which I told you up here is the same thing. Boom! Or approximately 12.6. Look at that. You guys are awesome. Last thing we got to calculate is right here. What is the length of YZ? Well, if I know these sides are congruent, again, set them equal. Add x to both sides, minus 4 from both sides. I get 8 equals 4x, sorry, cross out that one, which means, I don't know why I put negative 8. X equals 2. So I'm going to plug 2 into there, and I get YZ equals 3 times 2 plus 4, which is just 6 plus 4, or equals 10. Boom! That's the test. Crush this test. Peace out.